So hello everyone. So today we are going to learn this how to choose the loss function. So we'll be saying this thing. So this is going to be the sixth lecture of this series. So if you haven't watched the previous videos, then please go and watch. Link in the description. And let's go on the topic. So first thing I will tell that if you have started this video, then please watch till end. Yes, consistency matters a lot. So please watch till the end. And second thing is that if you like this video, then please subscribe. Like this video, subscribe it, and share it to the people who are really interested to learn machine learning. So this is going to be the basic of machine learning, and this book we are going to learn. So let's see. So we are going to see about how to how to decide that performance measure. What is the performance measure? Like it is actually the loss function. So what the loss function does? So just search about it. Like loss function. What it does? It is method of evaluating how well your algorithm models, your data set. Means that how much your model is good. That is the very simple thing. I hope you got it. That actually loss function tells you that okay, this is going to be loss, and this is going to be something difference between the true value and a predicted value. There will be always a true value, the actual value, and there will be predicted value from your model. If there is a more difference, then that model is not good. But there is very less difference. Like loss function is very low. It means loss is very low. It means that okay, the model is quite good. So there are two basically performance measures are there. RMSE, root mean square error. Like root is here, mean means divided by total number of the data or data points, and then there is actually the square. Square. This is the square, and this is the error. So HXI means this is maybe predicted one minus actual one, and we are squaring it and summing everyone, and then divide it by doing its average or mean, and then we are doing the root to nullify this square. So why we are doing a square? Actually, we are squaring it so that we can't miss the negative value. Just think, this is the picture. Yeah. Okay. This is the picture. Just think, this is the negative. This is like both are the like this is positive. This is negative. So like if we will add just now, maybe this and this will add up and it will give 0. Like there will be no error, but still there is error. Okay. So for avoiding this thing, we are just doing its square, and after that we will be doing it mean, and then after that we will be just give it a root to nullify this thing. Okay, fine. So like in the regression problems, we use actually RMSE. What the RMSE does actually? RMSE gives you that how much error is there in your predicted value with the actual data in comparison to the actual data. It gives an idea that how much error the system typically takes in the predictions, and a higher weight given to the higher errors. Just think, if there is high error, then it will penalize. Okay, it will like give some punishment by giving higher weight to the large errors, so there will be no large errors. That's why in the regression problem you use root mean square error. Okay. Then there is just C. Although that RMSE has generally preferred a performance measure for the regression task, but there is another function. Like if there is a many outliers, then in that case you may consider the mean absolute error. Okay, we'll see that why it is saying mean absolute error is good. First see here, Like it gives the idea of how much error a system typically makes in its prediction, with the higher weight given to the large errors. Okay, so this was the whole thing. Now, let's have this. Okay, and let's say, so this is going to be this is just take it as a graph. Okay, so take it like something, and there are very points, different points. Okay, okay, hold on. So here are a lot of points. I'm just putting it here. Like a lot of points are here, and it made actually a linear regression model. Okay, so if you made something like this. Okay, so that's why it give it another between. Now there are some points like here, which is it is called outliers. Means it is out of the box, something like that. Like it is out here. So it is actually distorting. It is not with compare, like in the sense of this thing. Okay, it is something out of this thing. That's why it is called outliers. So actually for this thing for this thing actually, or this, it actually, if there is a lot of outliers, then the error will be more, of course, because there will be large distance. As we learned, the rest RMSE actually gives the higher weight to the larger errors. So if there are a lot of outliers in the data, then there will be a lot of errors. There will be a lot of error, and your model performance will not good. But if there are a lot of outliers, then we use actually the another loss function that is called MAE, that average absolute deviation. It means that it actually gives a small weights to larger errors, like a smaller weights, not a small but a smaller, in comparison with RMSE. Like and like it consider it. Okay, and it actually it takes the distance, and it makes it positive. Okay, it makes the distance and make it positive, not a square. By squaring you make it double. Okay, like multiplied by double. Okay, so KME is used where there are a lot of outlier districts. So this was the whole thing. But let's see that how we can run the codes. So after this, we are going to have a hands-on learning full. So I'm just quickly going to show you that you can just open the you can just open the you can just open it in Google Colab. So what is Google Colab? Actually, Google Colab is you can just open it. Okay, so you can just click here, or yeah, I will just give the link. Okay, not to worry. So you can just open the Google Colab, link in the description. Just go and click the new notebook. So actually, Google has given it the Google Colab, which is uh, quite good thing, because here you can write your code, run online. If you don't have a very big system, or like a good system, then it is okay. So it is like you can just write it here that housing prices, and after that you have to just connect it. I'm just showing you that how to do it. Okay, and then you can just you can like import numpy as np. Okay, so you can do like this, and import pandas as pd. Okay, so here you can see that there are 12.7 GB RAM, and disk is 107.7 GB. So it's too much. Okay, so it is enough for our coding. So we will be running all the codes here only, and I'll be sharing you. So here you can just make a new file. So I'm just going to, like, here you can make new notebook. I'm just zooming it, new notebook, then open any notebook, or you can upload it. You can rename also, or like here you can also connect it to the GitHub, or you can just download by clicking it here. So it will be getting downloaded soon. Let's see. Yeah. So here it is downloaded now. So actually in it will be open in this format. Okay. So this was the whole thing of the Colab. I hope you got this thing. And this was a easy tutorial. In the next video, we are going to actually do the coding. So actually, we are going to download the data and do the actual coding. Okay. So I hope that you like this video, and please like, share, subscribe. And if you have any doubt, please comment below, and I will love to answer you all. And if you want to connect me on LinkedIn, please connect. Ask any queries. Link in the description. Thank you so much for this video.